Okay, students, we're going to talk about transformations today. Right now, we're going to talk about the real definitions and what you're going to see on the DCAS. As I told you, this book does not do a good job on this or even the next chapter. So we'll be bringing in more stuff from outside my resources that I've used over the years, which include these notes because they're all based off what's on the DCAS. So when I come back, then we'll go over what's in the book and what you need to know for the Edulastic test. But you're going to learn the right way right now. Okay, so transformations is a general overall topic that then include four types of rigid motions. Four types of rigid motions and one type that's not a rigid motion. So transformation is the general overall topic. If I go ahead and, if you want to write this down, if I can't remember if I've already had you write it down or not. If not, put this in your vocab. Okay, so you have transformations, and you have two types. You have rigid motions, which another name for that is isometry, or you have a dilation. So this goes on your vocab sheet, not in your book. Okay, yeah, know the difference. Okay, then within the rigid motions and isometries, okay, you want to think of the word congruent. These types are all congruent. Remember, that means the preimage and the image are exactly the same shape and size. Dilation, remember, almost all the time, 99% of the time, is either enlarged, so it gets bigger, that's bigger, or reduced. Okay, so dilation makes a shape get bigger or smaller. The words you need to know for those are enlargement or enlarged and reduced. Okay, we are only focusing today on two types of rigid motions. Now there's four types we have here. We have a reflection. Next one is translation. Then you have a rotation. And lastly, there's what's called a glide reflection. Now, the DCAS is only going to focus on these first three, just so you know. So instead of calling it glide reflection, for whatever reason, they just called a combination of a reflection and a translation. And that's what a glide reflection is doing a single reflection and then a translation, or you can do the translation first and then a single reflection. But that technical word for doing that is a glide reflection. So all of these deal with reflections, and the question is how many reflections? So a reflection is just one reflection. A translation is two reflections over parallel lines. A rotation is two reflections over intersecting lines. And a glide reflection is three reflections. Remember, I told you it's a single reflection, which is one plus a translation. 1 plus 2 is 3. So those are the number of reflections right there. Number of reflections. Okay. Translation is over parallel lines. Over parallel lines. And this is over intersecting lines. Okay. Now, these are the real definitions. Now, you're not going to be taught this in the Edulastic for this book because they don't use these real definitions. So, remember we did a pretest. Remember that pretest, we saw a reflection is over a line, translation is over a segment, and a rotation is over an angle. That's how you're going to answer on the test for Edulastic. But this is what you need to know for DCAS end of the year. Okay, so today we're going to just focus on these first two. Then next class you'll do rotations and dilations together. Okay, so 2 days on this. Okay, so now, so if you need to pause the video, go back, do that, get that written down in your notes, go ahead. All right, so here sort of scrunched together. You see types, translations, two reflected over parallel lines. You just wrote that down. Rotation, two reflected over intersecting lines. You just wrote that down. Reflection is a single reflection, and all reflections are at 90 degrees to the line. All reflections 90 degrees to the line in the same distance away, no matter what kind of reflection you're doing. Glider reflection is a single reflection followed by a translation, as I told you, or vice versa. You can have the translation first and then the single reflection. And a dilation usually makes the figure bigger or smaller. We call that enlargement or reduction. And remember, since it's not the same size as the original, pre-image and image are different. It's not a rigid motion. Rigid motion, as we see right here, is any way of moving all the points in the plane by one of our four isometries or rigid motions, either by translation, rotation, or reflection, or a glider reflection, not a dilation. So only these three are rigid motions. Another name for the rigid motion, as it says, is isometry. Dilation just falls into the category of transformation, but it's not a rigid motion, as you just saw and drawn out there. All rigid motions are congruent, as I pointed out. Okay, they always preserve angle measure and distance. These are on the DCAS. That's why I'm highlighting these. Rigid motion isometry, you got to know it. Okay, all rigid motions are congruent. The definition of congruent on the DCAS is if I can go from the pre-image to the image by either a translation, or rotation, a reflection, or any combination of those, which would be the glider reflection. They always preserve angle measuring distance. That's what, and so congruent, same shape and size is a simple way of saying it. Okay, in other words, if two figures are congruent, then you can move from the pre-image to the image by one or more of the rigid motions. Okay. This right here is an error. You can cross it out. This is actually a rotation of 180. So rotation of 180 reflects over the y-axis and then the x-axis, or I could have done the x-axis first and then the y-axis, and it'll still take me to the same point. That's a rotation of 180. Another way to see it's a rotation of 180 is if I take a point and its corresponding point and I connect them, it will always go through the origin. So it goes to the origin. If I connect this one and this one, it will go right through the origin. I connect this one and this one, corresponding points, it'll go right through the origin. So if I can connect the pre-image to the image, corresponding points, and it goes to the origin, that's always a rotation of 180. Okay, just so you know that. So correct that on your note sheet right there. All right. A transformation, remember that's a general overall, maps an initial image called the pre-image onto its final image called the image. Should be easy to remember. Pre means before, so that's the first one. Okay, translation, another word for translation is slide. It just slides. Its shape looks exactly the same. It's congruent, but it also is in the same manner. It's not rotated at all. It looks exactly the same. Okay. Now, orientation. Orientation can either be counterclockwise or clockwise. And since it's two reflections, it's going to have the orientation is going to remain the same. So whatever the pre-image orientation is, if it was clockwise on the pre-image, then the image will also be clockwise. If it was counterclockwise on the pre-image, then the image would also be counterclockwise. Versus when I have an odd number of reflections, which is that single reflection or the glider reflection, okay, which is three of them, remember, so one or three are odd numbers, that will switch orientation. Okay, that's why I have the word switches right there. CC for counterclockwise, just so you know, for shortening, or clockwise. Okay, but it switches on an odd number of them. Don't forget, the image has those primes with it. The pre-image does not have the primes with it at all. So here I can see a prime, and a prime. So this is the image down here. No primes up there on the pre-image. So they don't have to tell me which is the pre-image and image. If I see one with primes and one without, I know the ones without are the pre-image, the original picture. The image has the primes on them. Okay, that's just vocabulary. All right, the value of checking the orientation of the pre-image, the image, is that you can eliminate two of the four possible transformations. I should say, more specifically, rigid motions. okay, or isometries. Dang it. Rigid motion or isometry. Okay. Thus enabling you to more easily figure out which transformation map the pre-image to the image. The reason I'm using the word transformation is because that's what they'll say on the DCAS. They're not going to give it away that's a rigid motion because you might pick dilation. So they're just going to say transformations. The other two transformations are rotation and a glide reflection. If the orientation remains the same, your two possibilities are translation or rotation. We just talked about that. If the orientation switches, then you have a single reflection or a glide reflection. That's the 1 or the 3, the odd number of them. But remember on the DCAS, they don't talk about glide reflections, so your answer would just be reflection. Okay. Next, we have what's called a translation rule. You start with a point, like there. So here's what a translation rule looks like. X, Y maps onto, that's how you say it, maps onto is an arrow. And it tells you how to shift it. X, Y are the pre-image points, the original points themselves, however many they are. I'm just doing 1 point here. So this says add 2 to every X coordinate. So that means go right 2, and go down 3. Should be very easy. So I go right 2, 1, 2, down 3, 1, 2, 3. And so there, right there is my A prime. Okay. Now you could also just plug the numbers in, whatever the original X and Y are, plug in for X and Y, and I'll give you new points. But you should easily be able to see if it's plus 2. Since with the X coordinate, X is left or right. Plus is to the right. So that means right 2. If it's minus, that'd be left 2. Y is up or down. Since it's a minus, that means down. If it's a plus, that'd be up. Okay. So that's what a translation rule looks like. You'll see that on the DCAS. Now, it doesn't look like this. They don't do any of this on your test, on your Scholastic test. But again, I got to prepare you for the DCAS. That's the one that, okay. This is another way they could write a translation rule. Capital T, and they just say -1, 3. That means go left 1, down 3 from the original point of 3, -3. So there's 3, -3. It says go left 1, up 3. Left 1, up 3 puts it right there. And there's my A prime. I call the first one A. Okay. Now, the other thing they could also give you is they give you the pre-image and the image point. And they say, write the translation rule. Okay. So I do image point minus the pre-image point. That's why you see the arrows going up. I'm going to subtract image minus pre-image. So 8 minus a minus 2 is 10. That's why it says X plus 10, and 3 minus 2 is 1. So Y plus 1. Okay, there's my translation rule. Okay. So translation is very easy. It's just plus or minus, and you go left, right, up, or down. You're just counting. Okay. So on your assignment, you're not going to have too many translation rules, so those are real easy. So what our focus will be is on reflections. Okay. So reflections, I already told you before, at 90 degrees to the line, a reflection, and the same distance away on both sides. All right. So we have our key reflections right here. Over the x-axis, and that equation is y equals 0. Remember, we talked about this before. The y-axis, the equation is x equals 0. The origin is 0, 0. The line y equals x, and the line y equals -x. Here's the line y equals x, the most famous line in math, and y equals -x. Slope of -1 going through the origin. Okay. So those are reflections, our main reflections that we go around and deal with. Now, it doesn't have to be that. It could be y equals 2, which you're going to have on your assignment. Okay, so you're going to know y equals 2 is a horizontal line. Okay, now, pre-image image, here's the rule that becomes. They used A, comma B. You can use X, comma Y. It doesn't matter. Okay, what happened when I reflect over the x-axis? The y coordinate switches. That's why it says A didn't change at all. A is still A, but it becomes the opposite of B. That's what happens when you reflect over the x-axis. What happens when you reflect over the y-axis? The x-coordinate switches to its opposite. So that's why it says -AB. B does not, the y-coordinate does not change. If I go over the origin, okay, that right there is a rotation of 180. Rotation of 180, same thing. If I reflect through the origin, That's like a reflection over the x-axis and the y-axis. So that's why you see right there, there's the x-axis and there's a y-axis. So you see a negative a and a negative b. That's why the final answer is negative a comma negative b, because you're reflecting over the x and the y. You're putting both of those together into one. That's your rotation through the origin. You might say rotation through the origin or rotation of 180. Same thing. Okay. So down here, I pointed out how it's plotted incorrectly. 3, 2 would become negative 3, negative 2, which is over here. Not down here. That's negative 2, negative 3. Okay, so that example was wrong. I got this from a book. Okay. Reflection over the x-axis. See, 2, 3 becomes 2, negative 3. Same distance away, 90 degrees to the line, same distance. That was a distance of 3, that's a distance of 3. 90 degrees to the line, same distance away. Okay, one away in each. Okay, that's always how you do reflections. All right, so what's the rule for y equals x? The line y equals x, all you do is switch the x and the y. If it's over the line y equals negative x, you switch the x and the y and put negatives on both of them. So if it's over the line y equals x or y equals negative x, you switch the x and y coordinates. If it's a positive x, they stay positive. If it's a negative x, they both become negatives. That's the easy way to remember it. Okay, so you don't think of them as two completely separate things. Okay. So when you're doing this on your assignment, if it asks you for one of these rules right here, I want you to write down the rule itself like this. If it said reflect over the line y equals x, then I want you to write in x comma y maps onto yx. You don't have to use a and b, you can use x and y. If it said reflect over the line y equals negative x, I want this written down first, and then you go ahead and fill in your point values on the assignment itself. Okay? So that's a rotation of 180. All right. So orientation is either clockwise or counterclockwise, and speaking of figure, not a single point. So I just did single points here. Well, I did it for the first one. Okay. Switches orientation for reflection and glide reflection. That's 1 or 3 reflections. Translation and rotation stay the same. Okay. So notice this says reflection. We use lowercase r for reflection, capital R for rotation. That's how it's supposed to be. In your book, it's going to use capital R for both of them. Okay. And it says overline x equals negative 2. So I have to know x equals negative 2 is a vertical line where x is negative 2 every time. Y can be anything at once. So I draw that line. I plot negative 4, negative 3 right there. Okay, then I remember that reflections are at 90 degrees to the line, same distance away. So 2 away, 2 away. Right there then is A prime. Okay, if I have a little dot circle in the middle, that means following. So that means you go right to left. That's called function notation. So that means I got to do the one on the right first and the one on the left second. It says reflect over line y equals x following, that's that little circle, reflection over line x equals negative 2. So I'd first reflect over line x equals negative 2. Okay, so there's my pre-image. I reflect over x equals negative 2. It gives me that right there. Then over the line, why do I have this incorrect? Okay, so this is done incorrectly. It should have been over this right here, then over the line y equals x, which is just put it right over here like this. Okay, because my reflections are at 90 degrees to the line, same distance away. Okay. So I just count that distance to there, count to there, count the same distance away, put it there, and then reflect that. Remember, it's going to be same distance away 90 degrees. Okay, so that's got an error right there. That's not down here. Okay. So on these rules, since that's a straight rule, we have y equals x. Let's write down that rule. Okay. AB 3, 4. Oh, wait a second. I see what I know it's not wrong here. I was thinking this is my preimage. Here's my preimage right here. 3, 4. That one and 1, 2. So here's I'm going right here. Then I reflect over the line x equals 2. That puts it right there. Okay. So there's my preimage. This is my first image. And this is my second image right here. That's what happened. I wasn't paying attention to where I started from right there. Okay. So that is correct. Okay. So reflect over that. I got the point. So on the first one, I had to just count. Count to there, go out that same distance. Count to there, go the same distance. That gives me that point. Then with the reflection over line y equals x, it becomes yx, switch them. So then I go ahead and switch those right there. 4, 7, negative 7, 4 becomes 4, negative 7. Negative 5, 2 becomes 2, negative 5. Plot those two. Okay. And then reconnect them. And there's my image. Okay. Last example here. Again, we take our 3, 2 right there. Negative 3, 3 right there. Reflect over the x-axis. Remember that switches the y coordinate only. Okay, so that puts it over right there and right there. Then I'm reflecting over the line y equals negative x. Remember, I do right to left. There's my little O for following. I go right to left. That's why I said do this one first. Okay. And reflection over the line y equals negative x. Remember, switches the x and the y and puts negatives on both of them. So I went ahead and rename the A primes and put those there as negative 3, 3 and 3, negative 2. And then plugged into there, switched them, and put negatives on both of them. So it's best that, as much as you can, put your answers off to the side here, then plot them on the graph so you don't blow it. It's hard to necessarily always count correctly on the graph, so it's better anytime there's a rule. If there's a rule, obviously if it's reflecting over the line x equals negative 2, I literally have to plot them. There's no rule for over x equals 2, but if it's one of these rules up here that we have right here, write down the rule, okay, and plot and do the points first and then plot them afterwards so you don't blow it. Okay. Let me bring up where you have to, come on, come on, come on, paste. It's not want to come on here. Why do I not have it? Let's try to go to another page then. Let's go to another page and see if it'll come up. Why does it not want to come up? Let's hang this pen up and see if it'll work. What the heck? Insert notebook. Let's try that. I don't know why it wouldn't work. Okay. So let's say I have a preimage and image. I have this triangle right here. Okay. And okay, and I have that one right there. And we call this the preimage and this the image. Okay, without having to put all the points on there in primes. And so this can be on your worksheet as well. It's going to now say write the rule. Okay, so I need to write the rule for the reflection. If it's reflection, so A, B, C. This becomes A prime, C prime, B prime. So now if I look right here, this orientation is clockwise. This orientation is counterclockwise. Since it's switched orientation, that means it took a singular reflection. Remember, because they don't talk about glider reflections. So that means to be a singular reflection. So where do I find out where that line is? I take the midpoint of two corresponding points. So A and A prime. How far is that? 1, 2, 3, 4, 5, 6. So half of 6 is 3. 1, 2, 3. I can take the C's. 1, 2, 3, 4. Half of 4 is 2 right there. I connect those 2 points. and there's my line of reflection. So what's the equation of that line? X equals 1. So this rule would be a reflection of X equals 1 of X comma Y, of whatever my original point is. So there's the rule itself. Okay, you could just write reflection over the line X equals 1, and I take that for your answer. Okay, little r for reflection, capital R for rotation. Remember, we're not doing rotations today. That'll be next class. So when I check the orientation, if it switches, I'm going to come up with that line of reflection that it reflects over. Remember, all reflections are at 90 degrees to the line and the same distance away. There's my 90 degrees, same distance. 1, 2, 3, 1, 2, 3. 90 degrees to the line, same distance away. 1, 2, and 1, 2. Same distance. I could do the same thing with B and B prime. But you do have to know how to write equations of vertical or horizontal lines. A lot of kids still don't have it down from 8th grade math, Algebra 1 last year, and now in geometry doing it again. And they blow it on the tests because they'll write y equals 1 instead of x equals 1. Okay, so you knew what you were talking about, but you don't know your equation of your lines. You got to know that. Okay, that does it for this one, 26 minutes.